Okay, to do a stoichiometry problem, you always want to start with the problem, the amount given in the problem. So in this one, we're going to start with the 25 grams. Again, labeling is crucial for these problems. So potassium chlorate, there's 25 grams of that. Your next step is going to do the molar mass of potassium chlorate. I'm just going to kind of stick this out to the bottom. So I'm going to have 1 times my 39.10. 1 times 35.45, and again, but all these numbers are coming from the periodic table, and 3 times 16. So this is your molar mass, and all of that added together is 122.55. So on the examples on the other side of the worksheet, they only went to the ones place value. Your periodic table goes to the hundredths, so we're always going to use the hundreds place value, so we don't have a lot of rounding in our answers. So grams in 1 mole of KClO3. Okay. So grams of KClO3 remain, and we want grams of potassium chloride. So we are switching substances, so we're going to use the mole ratio of the balanced equation. So there are 2 moles of KClO3 for every 2 moles of KCl. So moles of KCl3 will cancel. And then I'm going to continue on the next line. Since I have moles of KCl on the top, I'm going to have 1 mole of KCl on the bottom. And again, I'm going to use the periodic table to get the molar mass of that. So 1 times the 39.10 and 1 times the 35.45 is going to give us 74.55 grams in 1 mole. Okay, I won't require that you do what I'm drawing under the line there. The molar masses, you should be okay on determining those. Right now, we've done that many times this year. So, and then like any other bridge problem, multiply on the top, divide on the bottom. These 2's will also cancel out, but they need to be in the problem to show that you understand that only by using the equation, coefficients of the balanced equation can you change from one substance to another. So, and if you calculate all of that out, you're going to get 15 grams of KCl. That's your final answer. And again, that goes back to sig figs, so 2 sig figs here, there's 5 sig figs here. These don't count, so there's no sig figs from the mole ratio. Those are considered exact numbers, and then 4 sig figs here, so because 2 is the smallest, you can only have 2 in your answer. Okay. For problem 2, again, we're going to start with the amount in the problem that's given. So again, these are always measured quantities. So we're going to start with 50 grams of N2. Again, grams don't react, it's molecules or atoms that react, so we're going to need to go to moles. So 1 mole of N2 is 28.02 grams. So again, 14.01 from the periodic table times 2 because N2 is diatomic gives us the 28.02. I'm not going to show the work for that from this one. And then coefficients of the balanced equation. There is nothing in front of the N, so that means there's 1 mole of N2. But for hydrogen, there is a coefficient of 3 for 3 moles of H2. So we need 3 times as much hydrogen as we do nitrogen for this reaction to take place. And to go to grams, we're going to go from moles to grams again using the molar mass of hydrogen, which is 2.02. So these are a lot easier mathematically as well. So then moles of H2 cancel, and you are left with grams of H2, which in this case will be 10.8. So since the 50 and the 2.02 both have 3, you're limited to 3. Okay. All right, question number 3 asks how many grams of ammonia are produced in the reaction in problem 2. So again, I'm going to start with what's given in part 1. So this time I'm just going to calculate grams of ammonia, which is NH3, instead of grams of hydrogen. Okay. So first part's going to be the same. I'm going to have 1 mole of N2 to 28.02 grams of N2. So my grams of N2 cancel. This time, though, I'm going to use a 2-to-1 ratio because I still have 1 mole of N2 in the reactants, but I only get 2 moles of ammonia for this one. So that cancels my moles of N2, and then 1 mole of NH3 is 17.04 grams when you do the molar mass. And again, moles of NH3 cancel. So when you multiply on the top and divide on the bottom, you get 60.8 grams. Now, you might have thought of an easier way to do this one. This one you can actually do a law of conservation of matter. So if I know I have 50 grams of N and I have 10.8 grams of hydrogen, since there's only one product, this will only work in a synthesis reaction, I can add those two together and get 60.8 grams because of the law of conservation of matter. So that won't always be an option, but that will work in this problem. You'll see in question number 4 and 5, since it's a double replacement, you won't have that option to do that. Okay. For problem 4, starting with 5 grams of silver nitrate. I'm going to try and find grams of barium chloride, or excuse me, let me undo that. We want to find silver chloride, excuse me, get ahead of myself here. So you're going to have 1 mole of silver nitrate and its molar mass, and if you calculate that, you get 169.88 grams. So those will cancel from the balanced equation. 2 moles of AgNO3 from the reactant side and 2 moles of AgCl on the product side. Again, you must show that, but like in the last one, the 2 moles will cancel as well as moles of AgNO3. And then 1 mole of AgCl and its molar mass is 143.32 grams. Moles of AgCl cancel, and when you calculate that, you get 4.2 grams of AgCl. Okay. Now, this one asks how much barium chloride we need, so I can't just subtract these two since I know this is 5, and I know that this is 4.2 because I don't know what this one is. So this one, there's no addition or subtraction we could do with law of conservation of matter to be able to calculate this one. So we're going to start with the 5.0 grams. I'll show you this 2 ways. It's always safer to start with the 5.0 grams of AgNO3 because that was given in the original problem. So we can really use any value. So I'm going to show it to you as well with calculating the 4.2 grams of AgCl, but if that answer is wrong, then your second answer will be wrong as well. So first step here, going moles to grams to moles is the same molar mass, so I don't have to recalculate that. So my grams of AgNO3 cancel. I still have 2 moles of AgNO3 from the equation, but this time I want to know barium chloride. So barium chloride doesn't have a number, so there's 1 mole of barium chloride for every 2 moles of AgNO3. So this time we use more silver nitrate than we do of the barium chloride. And then finding the molar mass of barium chloride at 208.23 grams is going to give us 3.1 grams of BaCl2 as our final answer. Now, just for illustration purposes, as I said earlier with stoichiometry, if you know one quantity, you can get all the rest. So 4.2 grams of AgCl, I can do this problem and still get the 3.1 grams of barium chloride, assuming that that answer is right. But again, I chose to do this first with the 5 grams because that was given in the original problem. So I'm just going to work backwards. This time I'm going to do 1 mole of AgCl, and I'm getting this number from up here, 143.22 grams of AgCl, and really that came from the periodic table. So that cancels. So 2 moles of AgCl, again the 2 coming from up here to the 1 mole of BaCl2, and the same molar mass as above. Okay. And canceling out all our like units, and this one also gives us 3.1 grams of BaCl2. So again, as long as your numbers are right, doesn't matter which one you start with. Now, we could do law of conservation of matter to figure out how much barium nitrate, but the question doesn't ask for that in this one. But so that is stoichiometry mass to mass. Okay, at this point, check Firefly for any follow-up assignments to this type of problem.